Hello again, cabinet makers. This session is for you if you want to get into CNC or already have a CNC but know that you could be more efficient and automated with it. I do think that automation is the name of the game if you're running a business producing cabinets. You can do a lot of fancy curved work and one-off pieces on CNC, but one of its biggest benefits to your business will be the rapid production of cabinets. So we're going to look at different aspects of CNC, but then really major on how you can automate your cabinet production. Quickly about me, so my name is Alistair Johnson. I'm from Sheffield in the UK. I design, make and install fitted furniture. I run a business called Freebird Interiors Limited with a small but very trusted staff team keeping things going at the moment. This is another example of our work, and one more here as we started to move towards CNC. Since I began the business on my own in my garage at the back of my house, I was sharing the story of business growth alongside technical how-to videos of the sort of work that we do. That was quite well received on YouTube and built up a bit of a following, which then led on to a membership site at buymeacoffee.com. So I also post there. In fact, I'm more active there currently than on YouTube. You can also find me on Instagram at Freebird Interiors or at Alistair_Freebird. The first talk in this series, which was given at Basecamp 2022 in Vancouver, is also available on my YouTube channel. So just search for Sketchup for Cabinet Makers from Concepts to Construction. That video will give you the foundation of understanding about the CabinetSense extension, which we're building on in this session to show the CNC functionality. To give you some context to the sort of work we do and the environment that we do it in, this is our CNC machine in our workshop. We now have a 2,500 square foot industrial unit. We've moved up from my garage. The CNC machine takes an 8 foot by 4 foot sheet and has 8 tool positions, an 8 tool changer. What I'm going to show you is very suitable for this sort of machine and any level of machine up from that. It will also be of some interest to you with a more hobby-sized machine, but if you are watching this just considering getting into CNC as a professional, I would very strongly advise that you get a minimum of 8 tool change capacity and a minimum of an 8 foot by 4 foot bed size. Here's another view of the workshop showing the panel saw. We've got an edge bander there, some workbenches just slightly obscured at the moment, spray booth and an assembly area beyond. Most of the work that we do is panel based, so we use a lot of high density moisture resistant MDF, which is sprayed for a very flat finish. That's part of our distinctive look. We also use melamine faced MDF as well as birch ply, oak veneer and some solid oak board and occasionally other solid woods, but we've really optimized our production methods for panel products. Here's an early example of a project we took on after getting the CNC machine. The material here, if you're interested, is a through-coloured MDF. It's the Finzer Fibrocolor board. And this particular project was longer than the bed of our CNC machine, but the design allowed us to conceal the joint. And I think this demonstrates very well the possibilities and the precision of CNC manufacturing. This type of project was planned in SketchUp. The detailing is basically quite unsophisticated, just a series of lines which were toolpathed with a V-cutter. This can be done in SketchUp. Actually, due to curve smoothing issues, I did the final drawing of these curves over in Vectric, which is the other link in the chain of software that we use to get to CNC. Here's a project which was designed entirely in SketchUp, modelled and remodelled after doing prototypes and remakes, checking very, very fine tolerances of these parts and remaking them in SketchUp, and then re-outputting to Vectric. And the way that I produced this 3D model and moved it through to Vectric and CNC is the way that many people are working in SketchUp. You do your 3D modeling, you actually draw in all your machining and your fixings, then you get that out to Vectric or similar software and apply toolpaths. There is a more efficient way for more standard work, so particularly carcasses, boxes. We can automate this a lot more in the way that I'll be showing you. Because the reality is that in a built-in furniture business or a kitchen cabinetry business, the bulk of your production is likely to be rectangular parts that need to be cut square and precise. With drilling for shelf pin holes, you need to ideally be churning quite a quantity of these through, know which part is which, and it's not the most inspiring part of your work, so you want it to happen as efficiently as it can. This is really the bedrock of your production. That together with doors, so over here you see these are shaker doors produced on the CNC machine. So with fast production in mind, I'm talking here about a flatbed CNC machine. There are certainly different types, but I would recommend a flatbed machine. And it is possible to do a lot of your production with face drilling only. And this fixing, the Cabineo from Lamello, is particularly well suited to that because it fits down into the face of the board with a screw that then projects from the edge, but is still very strong, very strongly held into the board. And that screw lines up with a 5mm hole in the mating piece, as I'll show you in the next slide. What we see here is Matt putting the Cabineos directly into the machined board immediately after machining. So he hasn't picked that board up and put it on another workbench. He's just cleared off the offcuts and the dust. And straight away, to minimize double handling, he's inserting the fixings. And those parts then just need to run through the edge bander, which is next to the CNC machine, straight onto a cart, and those are ready to go out to site for the installer to assemble on site. This shows you a little bit more about how the Cabineo fixing works. Those are your two parts, your 5mm hole. The installer will offer them up. The slight projection of the fixing here will self-locate into the hole before it's pulled nice and tight with this specialised bit. It works a little bit like a pocket hole joint. So as you can see in these examples of cabinets, we are putting the Cabineos on the outside, out of sight. We're also machining shelf pin holes and hinge holes and cutouts for sockets. Really, as much as we can, we will machine for speed on the CNC machine. So that's a bit of context about what we do, the sort of work that we produce. For the rest of this presentation, we're going to start with an overview of a specific project in SketchUp and as built, so we can see how we can go from SketchUp to CNC. We'll start by looking then at basic export methods from SketchUp into Vectric for toolpathing and then onto the CNC machine. I'll then give you an introduction to the CabinetSense extension, and as I said before, there's a bit more detail on that in the previous video, which should be linked below as well. And then we'll look at the CabinetSense export process into Vectric, where you can really supercharge the speed and quantity of information that you're sending through for CNC machining. And this is a template I was using for a live presentation where there was a Q&A, but do ask any questions in the comments below. This is the project we'll be looking at. SketchUp model on the left, as built on the right. This is a mixture of melamine internals, solid oak exposed parts, and sprayed high density MDF for the doors and other adjoining parts. Now that MDF is a Finsa product called Fibropan Hydrofugo. You may have seen in other videos on this channel we've chosen that as the best MDF that we've found for stability and flatness of finish, particularly with a water-based finish. Now looking again at the image on the left there, you can see that the machining data, including the hinge cup holes, Cabineo fixings, through screw holes and sockets for adjustable feet, are all there in Sketchup. This data is carried through for CNC machining, but as we'll see, I didn't need to draw any of those circles or cutouts. It was all automated according to rules that have been set up. So let's have a look at the SketchUp model. So I organise my SketchUp models using a template where I've got preset scenes that allow me to quickly isolate things, and I can add annotations which are unique to scenes. There are always some parts on a project that I don't send to CNC because it's really quick enough just to instruct my team to measure off the dimensions and go straight to the panel saw. So scribe strips, side cover panels. These don't necessarily have to go to CNC, but they could. So depending on the project really, they may be sent through if there are other parts of the same material and thickness that they may as well just be cut together. Let's have a look first at this shaped base. I've got a scene where I've isolated it, and I want to show you basic methods of export from SketchUp to CNC before we get into the CabinetSense extension. You can go right ahead and export, select 2D graphic, and then select DXF. This is a widely compatible CAD drawing format that you can bring then straight into Vectric to scale. I've done this already, but I'm just showing the process. So 2D DXF, that's one way of doing it. What you'll get is what you see, and it will come into scale. Another way of doing it is you can export that part as a 3D DXF, and there are certain benefits to doing that, which we'll see when we come through to Vectric. If you do choose to do that, I found that you need to rotate that part to be laid down flat, so you're looking down on the X and Y axis. So I've done that with this part, and what I've done just to demonstrate something is I've kept a version of it with the face and edges, so you see I can select a face there, and I've got another version of it where I've deleted the face. And I've actually converted both of these to just one face without the back edges. Let's go over to Vectric and explain why I've done that. So this is Vectric Cut 2D. You can get a free trial of this to give it a go. If you're new to this, what we're working with is a sheet which represents the sheet size that will lay down on the CNC machine. For my machine, the 0 axis is here, x0 and y0. We've already set up the parameters, so the size of the sheet, the thickness, etc. And we have a lot of tools where we can draw rectangles, etc. directly into Vectric. Over on this side we have the toolpathing, so once we've got geometry drawn or imported, we can start to apply toolpaths, profiles, pockets, drilling, etc. So I started off by saying that you could bring in a 2D DXF. So you'd go to your SketchUp model, you'd go to Export, 2D Graphic, DXF, and then you'd bring it in. The way you'd bring it in would be Import in Vectric here, Import Vectors. You'd find that file. So that came in to scale. But as you probably know with SketchUp, curves are not necessarily true curves. So you're going to get with that 2D DXF import, you're going to get the faceting of the curve. So these are actually straight bits with a little angle that approximate a curve. The benefit then of bringing in a 3D DXF, for reasons that I don't fully understand, but there's a quirk of the 3D DXF export process where it can identify an arc or a circle created in SketchUp, and it will export it as a true curve. in a way that the 2D DXF export process doesn't seem able to do. However, what we're seeing here is highlighted and dotty. There is the true curve, which it's reinterpreted back to an arc. But we're also seeing the facets, which are the surface. And you'll find that when there is a surface or a face in SketchUp on a 3D import, it often is shown with these various connecting lines sat on the face. So that's the reason why I experimented with stripping back that bit of geometry to just its edges, no faces. But for some reason in the process of doing that, the arc here didn't come through. So really the purpose of what I'm showing here is that there are certain quirks and limitations to that basic DXF export and import process. It's a bit limiting really for you to have to delete faces or get rid of these kind of lines as they come in. It's also limiting sometimes to have the facets when you want a smooth curve. And note here as well that parts are broken apart, which might affect the ease of toolpathing later. So the other way of going from SketchUp to Vectric is to do a save of your model in SketchUp in SketchUp 2019 version. Now this is because Vectric has an import facility, but it's currently only working with the 2019 version of SketchUp. So whatever version you're using, you will be able to save it as the 2019 type. And then once that's saved, you can come into Vectric and you'll be able to do an import process, but select the SketchUp model itself. So here's our 2019 version, and what will happen is a dialog box will come up asking you how you want to interpret those 3D groups and components within your SketchUp model, how Vectric should interpret them, because it needs to make a decision which is the face that you intend to machine. Do you want to smooth polygons into arcs, which is a benefit of this Vectric process? Do you want to only import data from certain layers? So you can play around with these settings. Now I've already imported just to save time, so what you'll end up with is it will dump in a bunch of parts with just a rudimentary nesting, so just laying them along an axis with a certain gap in between. And they will come in according to the layer that they're on in SketchUp, so the layers will carry through here. You can set that up to work for you. It will bring in shaped parts like this, and it will have a pretty good go at smoothing those curves. And note that it then does bring it in as a continuous boundary. You can then nest these, move them around. So it's a very useful feature. However, your parts of course aren't labelled, you've got to figure out what's what. Here we've brought in parts of the room, the coving in the room, door frames, text. You can discipline your model so that you only bring in the layers you need, but there are still limitations to this process. Still, let's just assume that we've brought our shaped part in by one of those processes just explained. Let's just have a little look at how we might machine that. So what I did for this part was, within Vectric, I added rectangles oversized versus my finished shape, zeroed down to the zero of my CNC machine, and then I placed my imported shape on top of it, selected it and toolpathed it with a profile toolpath. So I'll have set my depth plus my standard overcut into the spoil board and selected my cutter, which actually was a 12mm cutter, and so on. In Vectric you can then visualize the machining result that you're going to get. Just as a little double check that you are cutting right through, etc. And then what you do is you have your toolpath selected and you save your toolpath. So when you do this, what you'll be saving, if you're using the full version, is Gcode. So Gcode is what runs the CNC machine. So let's have a look at how that worked out in real life. What I did was I took the sizes I decided on in Vectric of my oak parts, and these were just cut using a panel saw and chop saw. I joined them for speed with the Lamello Clamex fitting, which self-clamps, because I wanted to be able to go straight to the CNC. And then I secured the workpiece to the base of the CNC with my centering pins down at the bottom left there, using masking tape on the reverse of the workpiece, masking tape also stuck down on the base of the machine, and super glue in between, which is a good method when your vacuum beds won't hold a thin piece like this. And then this was the result after I'd taken off the masking tape and cleaned up a little bit. So that's a great example of what CNC is good for, quickly creating shapes. If you can draw it, you can shape it. Before we move on to the carcass work, if you're fairly new to CNC, bear in mind that CNC is not the solution for every shaping operation. It can be tempting to try and make it do everything. It won't get rid of the hands finishing aspects you need to do. It won't be the right tool for certain processes like edge shaping. It may be worth investing the time in making it work for a process like that if you're going to do a lot of it. But very often, for example, the cutting of these joints here, we don't do this in this arrangement often enough for me to have set it all up in an automated way in the CNC machine. It was quickest to go straight in with a handheld Lamello Zeta P2 machine and get those joints done. When it comes to the carcasses, however, that is ideal for the automation that we'll be looking at next. So a recap of the basic steps from SketchUp through to CNC. Without any additional extensions for SketchUp, as long as you're using SketchuP Pro, you can just do a DXF export, either 2D or 3D, or you can save as SketchUp version 2019 and then import into Vectric. Within Vectric, you'll map your toolpaths onto your geometry. You make decisions about the cutter you want to use, the depth of cut, the speed of cut, etc. And then once that's all decided, you'll do an export process from Vectric to Gcode. So Gcode is just a series of instructions to the CNC machine, telling it which tool to pick up, telling it where to go, how fast to spin, how deep to cut, and then all the vectors of the cuts that it needs to make. So let's look at another faster way of exporting our SketchUp geometry to CNC using the CabinetSense extension. Go back to our original SketchUp model. Now if we just isolate our carcasses here, and I'm going to do an X-ray view. Each part here in this CabinetSense carcass has a lot of options that you can control. Now I get to this window using the CabinetSense toolbar, the CabinetSense's own components option button here. Now this part can have its material independently changed. Let's just change it back to the oak effect melamine. It can have settings like its positioning changed. I can choose to set the front in. And a range of other settings, including how I want it to be fastened to the adjoining parts. So I can specify that at the left I want a certain type of fastening, at the right a different one, at the back another. So wherever it meets a part, it's looking for an instruction about how it's joined. So having chosen these, which have been pre-set up in the background in a machining database, I can go out, select my whole cabinet, and then just do a little visualization process, so preview machining drill points. And that's going to show me the machining that's going to be exported in DXF for machining in Vectric. So I can just get a little visual check here that yes, that looks correct. The Cabineo is on the underside of the shelf. There's a through hole for a self-tapping screw. We've got my particular machining setup for hinge mounting plates as well. And then down here on the base cabinet, if I just preview that one, again with the machining preview up here, we've even got our socket holes to receive adjustable feet, because that particular part has been set up with that instruction. So our machining template has this type of foot. Now, the important thing to understand here is that at no point has it been necessary for me to come in, go to a part and start drawing the holes that I want to be cut. So you may assume that to get a Cabineo cut you'd have to be drawing in SketchUp, no more accurately than this of course, punching, but then you start to have these kinds of issues. Well, how exactly are we going to model that, and how is that going to be picked up in Vectric? Because if I do try to model a recess exactly how I want it to be, then when I export it I may find I get doubled lines and other issues, or overlapping circles which are then no longer identified as a drilling point for my 15mm drill. So it's really much better to not have to draw your machining in. So the way that it's generated is via a machining database. So CabinetSense comes linked with a Microsoft Access database that it refers to. If we click on the toolbar here, we will open that up. And this did take me a long time to get my head round, so I'm certainly not going to expect to fully explain it. But let's just give you an overview. If we go to our fastening methods here, I can set up methods, for example, Cabineo, just my 3 overlapping 15mm holes, which is applied under certain conditions. You have Cabineo plus this template, then we're also going to add some foot drilling holes. If you have a Cabineo for a part that is under this length, then we're going to have a certain set of spacings and different spacings at this length and so on. So as we look over here, what we're instructing is, if this is the conditions we're working with, then we want to have a Cabineo fastener 37mm from the front edge and 57mm from the back edge. And over here I've specified that I want to alternate with a screw fitting, that's just a through hole in between the two Cabineos. If we drill down to a deeper level, we've got the actual setting of the Cabineo itself. So we have hole centers here off the edge of the shelf end, or the part end, whichever part it's applied to, the diameter of the hole, and the depth that hole should be drilled at. So these 3 line items here are specifying those 3 overlapping holes. And then simply by choosing Cabineo here, we can choose how that pattern is mapped at the start, end, or center, or a repeating pattern along a connection. We also set up here the available tools, so that CabinetSense knows what tools we've got loaded in our CNC machine, and then can output the data to suit the tools available. So just before we look at that export process, what we're saying is we no longer, with CabinetSense, we no longer need to use these basic, slightly error-prone export methods, which leave us with parts in Vectric which we're not quite sure what they are because they're not labelled. We can use the CabinetSense extension in SketchUp, and then we have a direct export process to Vectric, which can include labels, the drilling information we've just described. We can automate the creation of the toolpaths onto that geometry and other automations that are taken care of. You can also use CabinetSense to output your parts to a simple cutting list or nested cutting diagrams for use on the panel saw, and that was demonstrated in the previous presentation. So how do we export from CabinetSense? Well, once you've got everything set up and that machining data is applied to each part as it should be, you can just sort of double check per part. See, we've got fasteners applied here. Of course, we can double check with our X-ray view and the preview machining as we looked at. You don't need the preview machining to be on when you do your export, and it doesn't matter really which view you're in. You don't need to isolate only your CabinetSense parts, because it knows that, for example, the walls that I've just drawn natively in SketchUp, they're not CabinetSense components. So all I have to do is hit export up here. I usually leave all these settings on because they don't take up much space, and I can go and just pick and choose what I want later. This creates a bunch of files that just get dumped into a specified folder, and it gives me a little report that it didn't find any errors, and another report screen here showing the tools that it's going to use for the required machining based on what I told it about my available tools on my CNC machine. So now that that's done, we can go over to Vectric. We'll start a new file, new project. Let's say we just want to bring in the 18mm thick oak effect melamine to start with for the internals. That's set up okay there. And what we'll do is we'll use a Vectric gadget, which is a DXF batch processor. So rather than one by one importing DXFs, we can just find a folder full of them and pull them in. So this is where all my project exports land. Yeah, so here we go, there's the folder. These are the parts for the so-called armoire. So we've got our big back panel, our small sides down below, and in this particular project I just labelled the lower short cabinet as A. So that comes out before the part's name, and the upper cabinet I labelled as B, so we can see there's the big back panel, starts off as B and then the back. But the naming conventions for the internal parts are already pre-set up within the CabinetSense components. The machining information has been generated, so these are perfect circles which are only really brought into existence at the export process. The visualization of these that you saw within CabinetSense was just a visual reference, but the true output is a perfect circle. And these have landed on a unique layer according to the machining that needs to be done. So what that then means is that we can very quickly machine this or set up the toolpathing for this via a toolpath template. Now of course we need to nest them properly onto the sheet, but just to quickly show you the process for applying the toolpathing, we'd go to Gadgets, and we'd use a CabinetSense gadget that can be loaded into Vectric. And what this will do is, if we bring in a preset sheet strategy, so this is a Vectric file with a lot of preset tool information, bring that in, tell it to apply, and it's going to do some clever work in the background where it's going to go looking for layers and taking from those layer names the depth information and automatically generating then toolpaths accordingly. That process does generate some redundant toolpaths because all the available toolpaths may not be required in this particular project. So we can just do a little delete. And here are the toolpaths. And we can see how it's been visualized with the direction of the tool cutting. We can change how it's visualized up here where we get a colored infill. And in fact what we have to do then of course is nest these, so there's a certain back and forth between the nesting process and the application of the tools, which I can't fully go into here, but within Vectric we have our own nesting options and we can get those parts onto sheets as they should be, remap the tool paths, and then we're ready to go to Gcode. So you can see the power of this. We know which part, we know what's the top of each part, we know what's the front, we even know when a part has a requirement for edge banding, because that's been set up in CabinetSense at the part level. And because our edge bander doesn't have pre-milling, we tell CabinetSense that whenever we've applied an edge band to a part, we want it to be sent to the DXF with the edge band thickness removed. So this part has been automatically reduced in its width by 1 millimeter, because we know that when we take it to the edge bander, that width is going to be added back on. So all of that is taken care of. Let me show you one more thing which helps to explain the unique strengths of SketchUp in this area. Now this part, which is a side panel that I could send for cutting on the panel saw, it is a CabinetSense component, although it doesn't fit within a cabinet. And if I just isolate it, as I've already done in a scene here, we can see that I've already been able to apply a profile onto the front edge. So although it does have parametric capabilities, it is still at that lower level of components. It is still SketchUp geometry, which we can mess around with the way we're used to. And it hasn't broken the parametric functionality for me to have just rounded over that front edge. So let's take that a little bit further. I can go to an arc here. So I mean, let's just imagine that we want to shape the back edge somehow like this, just using native SketchUp tools. I can punch that through using push-pull, so I've just tapped P for push-pull. I am just going to take off a little scribe instruction that's on the back that might mess with that. And then one more thing to show you so that we can see how it carries through to Vectric is if I wanted to punch a hole through that, then I could just do what I've done, draw a circle, punch through, but I could also use a CabinetSense tool, which is a cutter, and we can just pop that onto the surface, except we do need to drop down within it like this. So generally you need to open up a cabinet, drop it onto a surface, and that will stick to a surface of a part. And that component there can be set up to be a given diameter, so I could change that. And you can set it up to cut a certain depth, like this is a recess. I could just go right through, in which case I'd just put a big number. That's how it works. Put a big number in, you know it goes through. It's not going to keep cutting through, it just goes to the depth of the part. But let's keep it at 9 millimeters. One thing I do just need to do with this cutter component is let it know which face I want to machine from. So even though I've dropped it on the outer or exterior face of that part, I could choose to say I want it to machine from the interior. So go to exterior, apply, and then CabinetSense will take care of showing me this part on this face ready to machine into here. So I can just select that part, export, run. Yes, I only want to export that part I've selected. So generation seems to be okay. Come back to Vectric, and we could do our gadgets DXF batch process like we did before, but because it is only one DXF we're going to bring in, we can just go to import vectors. So here's where I dump my exports. This is the most recent export. That's a good little check that it's landed in a folder of the correct material, and here is the part. So there it is, it comes in, and we get our nice continuous outline taken care of by CabinetSense. Our part is correctly labelled according to whatever I've called it. Here is our pocket, so that's come through on a layer that you can see down the bottom here. Pocket, it's choosing to use a 12mm cutter. It knows it needs to be 9mm deep. That'll get matched up to a toolpath with our automatic toolpathing process. And we've also got a little indicator that that's the top of the part. So that's a starting overview of how the process works. Now the principles to keep in mind here are, if you're a small setup, just a one-person woodworking shop, this level of automation may not make sense for you yet. You may be quite happy designing and then making, and then perhaps taking a step forward from all the brain work happening in the making. You might start to move forward to a bit more of an involved design process, which hopefully then reduces your making time, especially if you do move to CNC. You'll have a lot of preparatory work, which will then reduce the construction time and hopefully reduce the time taken to produce the whole project. But what we're really moving towards here for businesses that want to fully embrace CNC and speed up their production is the creation of systems below the waterline there, before the project start date. If you have systems in place, then your design process can be rapidly sped up. Your construction process also with the CNC should be reduced, and your whole completion time should be reduced. Be aware though that the reality is the systems creation process can take a very long time. That was our experience. The power that's available in the CabinetSense plugin is an asset to you, but also something that takes a long time to figure out. There are many different ways of achieving the same thing, many different levels in the software at which you can specify a certain setting on a part. You can program it globally, or you can program it in at the part level. So be prepared for a learning curve, but when you get to this point, which we've now got to, each project then can flow through very efficiently. Do continue to follow my content. I may teach this in a more formal capacity in future. At the time of recording, my capacity to do that is limited as I continue to run the main business, but do ask if teaching has become available. And do comment. I'm really interested to hear what you think about everything I've shown today. Thank you.